Now we are starting with the third concept. We have done with Arrhenius, now we have done with Bronsted-Lorentz, and we are just left with the Lewis concept, right? So it is a short concept. So what is the Lewis concept actually? According to Lewis, acid is a substance which accepts electron, right? And base is a substance which donate electron. That means now in this case, you can say the Arrhenius, acid was a substance which was donating the hydrogen ion, and the one which was donating the hydroxide ion was a base, right? In the Bronsted, what was that? It was that the proton donor was an acid and the proton acceptor was a base. Now in the third case, what is it? Acid is that which accepts the electron. It is not donating the H ion, it is not donating the proton, it is just accepting the electron. And base is that which donates the electron, right? So now according to the Lewis, which substances are going to act as Lewis acid and which substances are going to act as Lewis base, right? So the one which will act as a Lewis acid, that means they have to accept an electron. So that means we have to focus on those substances which are in a serious need of electrons. So what are that? They are the one are that which carry the positive charge. That means the positively charged ions like Cu2 positive, Fe3 positive. We have many more ions. You know that the atoms with the positive valency can act as the Lewis acid because they have positive charge. They are in serious need of the electrons just to neutralize their charge. So that means they act as Lewis acid. Moreover, who can act as Lewis acid? Those one are in search of electron, in serious search of electrons. We have certain molecules like BF3, AlCl3. What they have? Actually, their octet in this, the aluminium is the central atom, in this boron is the central atom. Their octet is not complete. So that means the molecule whose octet are not complete and they need an electron can act as Lewis bases, right? Sorry, the Lewis acid. That means the molecules whose octet is not complete, they can act as Lewis acid. Moreover, we have seen certain molecules like SiF4. What we get to see in that? In this, the silicon has the d orbital, the vacant d orbital, and it can accommodate more electrons in it. So that means any molecule in which the central atom has a d orbital and can extend its oxidation number, or you can say it can accommodate more electron, can act as Lewis acid. So similarly, SiF4 act as a Lewis acid, right? So these are you can say the substances, and moreover one more you can say the factor which is responsible, or you can say the substance which can act as a Lewis acid is that suppose we get to see a compound like CO2 or any other compound in which, or I'll just explain you with a general example. Suppose there is a bond in which one is an electronegative and one is electropositive. So they occur a positive center. So that means here negatively charged, you can say this center can accept actually the proton to neutralize its charge. So these four substances can act as a Lewis basis. Now just look at the board that which substances according to the Lewis can act as a base, or what are those substances which the Lewis just called them as Lewis bases. So obviously those substances are going to act as Lewis bases who contain an extra electron. So that means the substances which possess the lone pair, they act as electron donor like NH3, like H2O, and moreover we have many like RNH2. So we have many, they have lone pairs. That means they have an extra electron which they can donate to someone. So they can act as a Lewis base. Similarly, all negatively charged ions like chloride, bromide, iodide, hydroxide, whatever, all negatively charged the ions, they contain the extra negative charge around them which they can spread towards the other atom as well. So they act as a Lewis base. Now let us see that how the bonding occurs between the Lewis acid and a base. Suppose I have an example of BF3 and I have an example of NH3. So what do I get to see in BF3 and NH3? In BF3, boron has only 6 electrons around it. That means the octet is not complete. And in case of NH3, what do we get to see? Octet is complete, and moreover there are bond pair as well as a lone pair present in it. That means there are extra electrons which are present in the ammonia molecule, right? So that means it act as a Lewis base because it can be an electron donor, and it can act as a Lewis acid because it is in serious need of electron, right? So they will just, what they do, they will just pair them, and the bond between them will be a coordinate bond because the shared pair is donated by only one molecule. It is not contributed by the other one, right? So like the ammonia has this kind of structure, this lone pair, it will be donating to the BF3. So it will lead to the formation of a coordinate bond and a linkage between the Lewis acid and the Lewis base. So this is how the Lewis acid and the base just get linked with each other. You can say the principle behind is that the one substance should contain an extra electron and the other should be deprived of electron, so that they can just fulfill their needs. They can just give their extra negative charge and they can have the electron which they are in serious need of, right? So this is how the Lewis concept, Lewis just gave his concept, but still it was a, you can say, a general explanation, but still there were few limitations, right? Because as the Lewis explained the concept, he always explained the concept on the basis of coordinate formation of coordinate compounds, but it is not always there that there is a formation of coordinate compound. There can be Lewis acid and a base, or acid and base can react with each other without the formation of coordinate compounds. This evidence actually came from, as we know that coordination, the formation of coordinate bond is a slow process, but acid base reaction is a very fast process. So that means not always the coordinate compound is present, or not always the coordinate bond is formed, because the reaction occurred, there are few substances who react very, you can say, at a faster rate. And so that means it was not explained by the Lewis. He was unable to answer because whatever he explains, he just explained on the basis of the coordinate compound, formation of coordinate compound or a formation of coordinate bond. Moreover, he didn't take into the consideration about the strength. See, I didn't explain you anything about the strength, that yes, according to the Lewis, he said this is going to behave as a strong acid or it is going to behave as a weak base. He doesn't mention these kind of words, but we need to have the strength also. We do have, see, you know that the degree of dissociation is something, an important factor. So that means we need to have the acids on the basis of the strength as well. We need to have the strong acid and the weak base, or a weak base or a strong acid. We want those categories under this. So Lewis just failed to explain this category. So this is what the concept of the acid and base, that is what we discussed. That is the, you can say, one was the just what they were just seeing or what they were smelling, and they just give those concept, that is the operational definition, and this is actually the conceptual you can say the definition. So Arrhenius just explained on the basis of H and OH, you know that now. Bronsted explained on the basis of proton donor and proton acceptor, and the Lewis gave its concept on the basis of electron acceptor and electron donator. So this is how the concept of acid and base was explained.